Hey everyone, I am Manish Kumar from Sri Venkateswara College of Engineering, holding USN 1V20CS 083, and currently I am studying in 8th semester. And I am going to discuss today about a topic. It is a like good topic from IoT and trending technology and IoT from the IoT technology. So I am going to discuss about the exploring the impact of edge computing on IoT. Let's start with our first slide. Let's discuss from the introduction of this topic, introduction to IoT and edge computing. First we will define IoT and then in further we will define introduction to edge computing. Definition of IoT is actually Internet of Things, refers to the network of interconnected devices that collect, exchange and analyze data to facilitate automation and decision making. And the second is edge computing. What is edge computing? Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed, improving response times and reducing bandwidth uses. Let's move towards our second slide and we'll discuss more about this topic. The second one is how is the evolution of IoT architecture? Traditional IoT structure. Centralized data processing in cloud servers, leading to latency issues and bandwidth constraints. Introduction of edge computing. Integration of edge devices and gateways for processing data closer to the source, reducing latency and improving scalability. That means it will improve the data latency. That means the when the data is fetched, it will be reached to the customer or the user at very small time. That will increase the latency of the it will reduce the latency and also the improve it will also improve the scalability. That means scalability means when you want more resources then it will be available at more, and when you want less resources then you can decrease the resources as per your requirement. That means it is scalability, it will provide scalability. Let's move to our second slide. Let's discuss about the key components of the edge computing. What are the key components of the edge computing? There are three actually: edge devices, sensors, edge devices, edge gateway, and edge servers. Edge devices consists of sensors, actuators, and IoT devices deployed at the network edge to collect and transmit data. The second one is edge gateways. It intermediate devices that aggregate, reprocess, and filter data before forwarding it to the cloud of data center. And the third one is edge servers. Servers located at the network edge that perform data processing, analytics, and decision making in real time. And the third, coming to the upcoming slides, we will discuss about the benefits of edge computing. The first benefit is reduced latency. That means processing data closer to the source reduces latency and improves response times. It is critical for application requiring real-time interaction. That means how we will reduce the latency by keeping the source closer to the resource, so it will reduce the latency. That means fetching time it will reduce, so user will be get the data in the minimum time, so it will reduce the latency. The second point is bandwidth optimization. Edge computing reduces the amount of data transmitted over the network, optimization bandwidth usage and reducing costs. Third one is improved reliability. Decentralized architecture improves fault tolerance and resilience, ensuring continuous operation even in the event of network disruptions. In the next slide, we will discuss about use cases of edge computing in IoT. What are the use cases we are using in the IoT that we are going to discuss about in this section? So let's start with the industrial IoT use cases. The first one is how IoT and edge computing are used in the industrial uses. So real-time monitoring and predictive maintenance. In manufacturing plants, optimization, production efficiency, and reducing downtime. What it means? It will be used in the industry for real-time monitoring. Suppose if you wanted to monitor something in the real time, then we will be using IoT. And for maintaining something, suppose you are servicing a bike, then it will maintain. It can be done by the maintenance can be done by the IoT in the industrial sections, and also it will be used in the manufacturing plants. Like suppose if you are manufacturing a plastic cup, then it will be helpful in the that also. And optimizing production, that means it will optimize the production, that meaning that it will optimize in the minimum time or minimum time and minimum cost. It will produce the more product, that means efficiency will be increased, and also the time it will take less, so it will be downtime, reducing downtime. And the third one is smart cities, that like we are using these things in the traffic management, environmental monitoring, and public safety. Application benefits from edge computing ability to process data locally and respond to events in real time. And the third one is healthcare, how we are using this in healthcare sector. Remote patient monitoring, medical device integration, and personalized healthcare services leverage edge computing for fast, reliable data processing. We are using this IoT and edge computing in industrial IoT systems, smart cities for traffic management, environmental monitoring, and all. And the third one is healthcare. It will be used for the remote patient monitoring. Like suppose someone is on home hospitalized, then we will be able to monitor that in by using the IoT things. And medical devices also. So we can integrate some medical devices through here to there, and we can operate from somewhere else to the somewhere other persons. So it will leverage these things. So leverage services is computing for fast, reliable data processing. And the next slide we will discuss about the challenges and considerations. What are the challenges and considerations while using these things? The first one is security and privacy. Edge devices are more vulnerable to cyber attacks, requiring robust security measures to protect sensitive data. There are very sensitive data which need to be protected, so it will be challenge for the IoT devices that. And the second one is scalability. Managing a large number of edge devices and gateway poses scalability challenges requiring efficient management and orchestration solutions. Like in orchestration solutions, we are be using OpenShift or Kubernetes to increase or decrease the replicas, or we can increase it and decrease it as per our use. Suppose if we wanted more resources, then we will be increasing the replica, and if you want less resources, then it will be decreased, so we can decrease by using the orchestration tool that is used for the scalability of the IoT devices. And the third one is interoperability. Ensuring interoperability between heterogeneous edge devices and platforms is essential for seamless integration and data exchange. Next slide, we will discuss about the emerging trends and future outlooks. What are the emerging trend and future outlooks of this topic? Integration with AI and ML. The convergence of edge computing with artificial intelligence and machine learning enables intelligent decision making and predictive analytics at the network edge. The second one is edge to cloud continuum. The emergence of hybrid architectures that seamlessly integrate edge computing with cloud resources, offering flexibility and scalability. And the third one is edge as a service. The rise of edge computing platforms and services that enable organizations to deploy, manage, and monetize edge applications. In the next slides, we will be discuss about the case study. What case studies we did? Edge computing deployment. Example: deployment of edge computing in a smart grid system to monitor and manage energy consumption in real time, reducing cost and improving grid stability. The second one is key success factors. Collaboration between utility companies, technology vendors, and regulatory bodies to design and implement an integrated edge computing solutions. And in the next slide, we will discuss about the conclusion. What is the conclusion of this discussion? So recap of key points we will discuss. Edge computing is transforming the IoT landscape by enabling real-time data processing, reducing latency and improving reliability. The second is importance of edge computing. As IoT becomes more demanding in terms of latency, bandwidth, and reliability, edge computing will play a crucial role in meeting these requirements. Call to action. Organizations should explore the potential of edge computing in their IoT deployments and invest in technologies and solutions that enables efficient and scalable edge computing architectures. That's it about the discussions. Thank you. Thank you. Thank you.